Now, let's go through the corrections of the homework you had yesterday about the different types of roots, real, distinct, equal, or imaginary. So, question 1 asked you to say, by inspection, so they mean by looking at the graph here, state which of these curves, F, G, or H, have. So, this isn't a minus sign, by the way. This is just a dash. If it's confusing, we can scribble it out. So F, G, and H. So which of them have real and distinct roots? If they're real and they're distinct, if they're different, they must cut the x-axis at 2 places. So only this blue curve here, F, cuts the x-axis at 2 different places. So F has real and distinct roots. Which of them have real and equal roots? So real and equal means that they touch the x-axis at one point. So only one curve does that, and that's H. Imaginary roots means that it doesn't intersect the x-axis at all. It hovers above it. And it's always going to be above it, because if it were below it, unless it's an upside down graph, so if it's U-shaped, it has to be above it, and if it's N-shaped, it has to be below it if it has imaginary roots. So this guy here, G, has imaginary roots. In the case of real roots, estimate from the graph the values of the roots. So for F, for the graph of F, we would estimate that the roots are at x equals, looks like about halfway through, or maybe 2/3 of the way through. So 1 2/3, I'd say 4/3. And the other value looks like 4 1/3, so I would say 13/3. But if you said 1.5 and 4.5, I'd accept that, but you can see it's not quite halfway. And then for G, or sorry, for H, there's only one value, x equals 3. Okay, so hopefully that was easy enough. Question 2 then. We're shown a curve here. It's a quadratic equation in the form ax squared plus bx plus c equal to 0. And we're asked to find, in terms of a, b, and c, the coordinates of the points a and b. So this is interesting. We could estimate from the graph, it looks like 1.5 and 6.5, but we don't know for sure. Okay, so we can't, this could be a square root. This could be like the square root of 2 or something like that. We don't know for sure. So they want us to give our answer in terms of A, B, and C. That means they want A, B, and C in the answer. And we're going to use the minus B formula because that's how you find the values. So the values are x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay, we're not filling in anything for it. We're just saying that the point A, actually the point A is the smaller x value, so that's going to be the minus answer there. So the point A will have x equal to minus b plus the square root of b squared minus 4ac all over 2a, and the y value will be 0. And the point B is given for the plus value. I'll just make that a little bit clearer. So B has the bigger value, so it's going to be the plus value. Minus B, I wrote down minus and then I filled in plus here, sorry. So this should have been minus B, take away the discriminant, and this will be minus B, add on the discriminant, b squared minus 4ac all over 2a, and the y part of the coordinate will be 0. Okay, so what they were looking for in this question, and it is kind of confusing the way it's asked, was to just illustrate that you understand that the minus b formula that we've learnt off gives us the coordinates of the roots. So minus b formula gives us the roots. That's what we were being asked for there. The roots come from the minus b formula. And they weren't asking us for actual numbers in this question. Now, in question 3, you have to find the discriminant of each of the following and state if the roots are real and different, real and equal, or real and imaginary. So we're going to not actually find the roots, but find the discriminant in each case. Question 3, I'll do it on some paper so that we've got space to work it out. So 3, part 1, A is 2, B is 1, and C is 5. And then we fill in 2, B squared minus 4AC without the square root. Without the square root, these are discriminant. So for part 1, my discriminant is going to be 1 squared minus 4 by 2 by 5. And that's going to give me a negative number. I can see that straight away. That's minus 39 when you put it into your calculator. So therefore we have imaginary roots. Part 2. Part 2 is here. A is minus 2. Now you could, the minus b formula works even if you have a negative in front of the x squared. You could change all the signs if that's what you prefer to do. B is 3 and C is 1. I'm just thinking, do you know what? Let's change the signs. Let's do it the way that we're used to seeing it. There's a minus there and a minus there. So this becomes plus, this becomes minus, and this becomes minus. Plus, minus, and minus. We should get the same answer either way. Let's just make it more familiar to ourselves. So we have b squared minus 4 by 2 by minus 1, and that gives us 9 plus 8, which is 17. So we have real and distinct, real and different. Okay, suppose I hadn't changed it. Suppose I had A equals minus 2, B equals plus 3, and C equals plus 1. Then I'd have gotten D equals 3 squared minus 4 by minus 2 by a plus 1. And hopefully you can see there, still get 9 plus 8, which is 17. So we get the same answer. Okay, part 3. A is 3, B is 2, and C is minus 1. So my discriminant is b squared minus 4ac. Whenever either a or c is negative, we're always going to have real roots. And you can see why. Let's move these up. So we have, this is 4 plus 12, which is 16. 16. Now that's a perfect square, so they'll be real and different, but they'll also be rational, as we noted at the end of yesterday's note. Real and distinct. Okay, fold this up a little bit so we can see it. Sorry if that's a bit noisy. So for part 4, we have, now be careful, we've got C, B, and A. It's written in the reverse order. If we want to use the minus B formula, A is not in order. A is the x squared coefficient. So let's just write these as minus x squared plus 2x minus 3 equal to 0. And hopefully you'll agree that those are the same thing. But in this case, A is minus 1, B is 2, and C is minus 3. I'm not going to change the signs this time because I've already shown you that we get the same answer whether we change all the signs or not. So A doesn't have to be positive for the minus B formula to work. And D is going to be B squared minus 4AC. And that gives us 4 minus 12, which is minus 8. It's less than 0, so therefore we have imaginary roots. Okay, part 5. Part 5, we've got x squared, so A is 1, plus 8x, B is 8, and C is 16, my constant. I'll fill that into my discriminant is B squared minus 4AC. And we get 64 minus 64, which is 0. So for the first time we have real but equal roots. If we used the minus B formula to solve that, we would just get one answer, and that would be where it touches the x-axis. Part 6. Again, they've written it not in the order that we expect, so let's rewrite it. X squared minus 10x plus 25 equal to 0, meaning that A is equal to 1, B is equal to minus 10, and C is equal to 25. And when I fill into my discriminant formula, I get B squared minus 4AC, and that's 100 minus 100, which is 0. So again, we have real equal roots. There we go. So that was the homework. Just zoom out a bit, see it all in one go. Now, before we move on to the next topic in our notes, I feel like we should do a little bit more practice. So I'm not going to give any new notes today. I just want you to practice with a few more questions in the book on discriminants and the type of questions we had in our notes where you're finding a missing value like a K or something like that. Okay, thank you.